Three, two, one, zero.
Hello and welcome back, everyone, to another episode of Ground Control here on Queen City News Plus. I am one of your co-hosts here, meteorologist Andrew Brightman, and of course, I've got my main man here off to my right, Mr. Matt Campbell, executive producer and also major space aficionado. How you doing, buddy?
I'm doing well. How are you?
I'm doing wonderful. So today we are going to be taking a little bit of a detour here. We've been talking so much about Artemis 2 going back to the moon, but also there's a lot else going on here with NASA and outer space. We had such a huge launch a few years ago. We have another big launch coming up. We're talking about space telescopes here, and we are really fortunate to be joined today by Dr. Begonia Vila. She's an astrophysicist. She was one of the instrument systems engineers on James Webb Space Telescope. She was the one of the lead engineers for the Fine Guidance Sensor. We are going to be talking about all of that and more here over the next 25 to 30 minutes. Dr. Vila, how are you doing today?
Very good. Thank you for having me.
It's absolutely wonderful to have you. So, as we first get into this, Dr. Vila, I looked up you're originally from Spain, and then eventually it made your way to Canada, and eventually here to NASA, working on James Webb and all of our space telescopes. Just tell me a little bit about your journey. Really, what got you first interested in astrophysics and actually becoming an engineer on a space telescope? I'm just kind of curious about your science journey to that point.
Yeah, I think I was always fascinated by the night sky. I was lucky to live outside a big city where the skies were dark. So, seeing the different stars, the moon. Of course, when I was young, I didn't know there was such a career that could study that. But then I did become an astrophysicist. And I took my PhD and worked in the university in the United Kingdom, and then moved to Canada. And in Canada, the big change for me was to leave the university and start working on space companies that still launch space telescopes to space. And there I became what we call a systems engineer. So I haven't done any engineering per se, but a systems is somebody that has the big picture of whatever you are going to build. And you're going to talk to all the disciplines, optics, mechanical, electrical, astrophysics, to make sure what you are building is going to meet what you need. And then lucky to start working on the James Webb Space Telescope. As you know, it's an international collaboration from the European Space Agency, the Canadian Space Agency, and NASA, and many other private industries. And two of the instruments come from Canada, which were the ones that I was the lead for. One of them is one of the science instruments, NIRIS, and the other one is a key instrument, which is, as you mentioned, the Fine Guidance Sensor for the observatory. And I still support Webb, which is so exciting for me I'm sure we'll talk about all the amazing discoveries it's doing, but I'm also lucky to support the next flagship mission that NASA is launching, which is the Nancy Grace Roman Space Telescope.
One thing that I kind of, when I was reading your bio, finding out a little bit about you, was that you went to the University of Manchester, and then you also worked at the Jodrell Bank Observatory. So
Yes.
you can tell us, what's your favorite British food?
Well, does it have to be fish and chips? I don't know.
That's probably.
But yeah, I mean, it's such a good point because I was coming from studying in the Canary Islands, right? And over there, there are some solar telescopes, right? If we want to observe our star, but most of them are optical telescopes, right? And I was used to looking at galaxies and how they looked on the optical wavelengths. And then going to Yodler Bank for my PhD, was my introduction to something maybe we'll talk about, which was receiving information from the universe in another wavelength, in radio. And those images, I still remember, they look so foreign to me at the beginning, right? How they look, to then obviously now working with telescopes that look in the infrared. And another cool thing, maybe just to mention, obviously optical telescopes have these mirrors that are perfectly aligned. We have to be so careful not to get them dirty whilst we are building them and keep them as pristine as possible. The radio telescope is made of metal. And when I was doing there, we climb on the telescope occasionally, right? So it was another different concept for me.
You're looking at a literal spectrum, wide spectrum of things. What's something that you found most interesting about that?
Yeah, I think it's super fascinating. We are used to our eyes, right? In our eyes, we know we can see all the colors. And that gives us information about anything we see here, right, on the Earth and also in space when we use filters. But this understanding that these objects on the universe emit, high energy X-rays that we cannot see from the ground. They also emit in the infrared and the microwave that, again, we cannot see from the ground. So definitely I remember as part of my PhD, we were studying at the time galaxies, right? They rotate around the center, the arms of the galaxies. At the time, a super important astronomer, Vera Rubin, was already indicating that those galaxies rotate faster than what they should be doing based on the amount of mass that we see, the amount of stars that we see there. So that was the introduction of this unknown that we still have, this dark matter that affects what we see, but we cannot see it. But on the center of those galaxies, there was something really bright. And the discussion at the time was, could it be that many stars are being formed there? Or could it be something like a black hole, which at the time was known, but very exotic, right? And now, I mean, we know there is a black hole in the center of our galaxy. We think maybe all galaxies have black holes. So for me, it's fascinating. This is what we think are exotic ideas, but that as we learn more, they become the norm, and then we keep learning.
Dr. Vila, what exactly is the fine guidance sensor? How did that work? What role does that play with the James Webb Telescope? How crucial is this instrument in making everything that we see and all the new discoveries that we're making so crucial?
Yes. So when you send a telescope into space that far away, James Webb is 1,000,000 miles away, right? 4 times the distance of the moon. You want that observatory to point to different parts of the sky, and it will slew with the star trackers to a certain location. But really, you need to keep that telescope really stable when you are observing and make sure you're pointing correctly. So the fine guidance sensor, when you get at the end of that slew to that part of the sky, is going to find a particular star and provide information of where that star is, so the observatory can be pointed exactly how the science instruments want it to be. And then it's going to provide the position of that star many times, 16 times every second, to a kind of closed loop information, right? There is an attitude control system that is going to notice if that star is moving a little bit and is going to be making these corrections, so that observatory remains steady and stable whilst the science data is being taken. I say it is similar to what we do when we are trying to take a picture here on the ground, right, with our camera. If we are moving that camera, any picture or spectra we take will be blurred. So we do that. So the fine guidance sensor is always key to make sure science can be taken.
Now, you were talking about how the James Webb Telescope is 1,000,000 miles from Earth.
Yes.
The one telescope that everybody remembers from the 90s was the Hubble. So why, and that's in Earth orbit, so why does the James Webb have to be so far from Earth?
Yeah, Hubble is looking at the world mainly on the visible, a little bit on the ultraviolet and the infrared. But James Webb was designed to kind of look back in time, right? Look at the first galaxies and stars that form in the universe. see how they change and evolve to become the galaxy where we are, and a star like our sun, and eventually a planet like the Earth. So the light from those objects has been traveling for billions and billions of years. And what that means is the light is going to stretch, right? And if the wavelength stretches, that means it moves to the infrared. So Webb needed to observe on that infrared. Infrared is heat, so everything emits heat. So it needed to be sent far away, and it also has this big sun shield, kind of a beach umbrella, and that keeps the instruments and the mirrors really cold at 40 Kelvin, very close to absolute zero, to be able to cool it down and then detect the heat of those very faint objects. And that's something we needed to do from there. And then we are in a special point, right? We want to be somewhere where the gravity kind of nulls out between the sun and the Earth. So if you place something there, it's going to be pretty stable. So we don't have to use fuel, a lot of fuel, to keep it there, right? Fuel is consumable. If we run out of fuel, the mission is done. So there are these special points where we launch these space telescopes, in this case, the Lagrange 2, and then keeping that infrared, keeping it as cool as possible for the science that it needs to do.
Yeah, and you were just talking about the Lagrange points. I felt like I was back in college. We had to learn about that stuff when I was in some of my calculus classes. But you were talking about also making sure everything is just so on point here in terms of if there's something wrong with the telescope, you can't. There was an issue with the Hubble back in the 90s. They had sent the space shuttle to fix it. With James Webb, there was everything has to be perfect. If something is wrong, basically the mission is kaput. How nervous were you and some of the other engineers when it was launched and it was going out to the Lagrange, the L2 point here, and waiting for those first images to come back to make sure they weren't blurry? Everything was sort of on point. Was there any type of biting nails, a little bit of anxiety waiting for those first
Yeah.
images to come back?
Indeed. I mean, this is still the largest and most complex telescope we have launched to date into space. And as you all probably know, it has those mirrors. We wanted a bigger mirror to collect more light and see fainter things, but it's made of 18 smaller mirrors. It has that big sun shield that when it's open is as big as a tennis court. And all of that had to be folded to fit inside the rocket. And we had to open it once we were in space. And then James Webb had something that we don't like to send into space, which are what we call single point failures, items that if they fail, it could be the loss of the mission. But unfortunately, to be able to do these deployments, we needed to incorporate one of those. We had a really big testing campaign on the ground to make sure everything was working. But even so, when we launched from French Guiana, we have that first week, 2 weeks, where everything is being opened up as we travel to our final destination. And it was every day something else had to happen. So we had the elation that, today everything went well, let's come back tomorrow, and the next thing has to happen, right? The sun shield has to open, the antenna, the solar array, the mirrors, we have to align it. So I think we were all cautiously optimistic, but also very nervous. And once we had the sun shield open, which we could see because we had the telemetry, the information from the instruments, we can see they start cooling down. So we know through all the telemetry, we knew, we cannot see it, but we know it's working. And we had the mirrors open up, then we knew we had a mission, right? And then it was just amazing when we were taking the first images for the calibrations, and we already knew what a wonderful telescope this was going to be, more even so than what we expected, and that has been the case, right? It is doing amazing discoveries every day.
And the images, the images that that NASA's put out have been absolutely stunning. They're portrait quality, if compared to some of the fuzzy stuff we used to get. But I mean, these images, the nebulae that we're able to see, the distant galaxies, it's just
Yes.
amazing to see
It's
this way.
Indeed, it is exactly. And we could sense all of this even during this commissioning period, right? But now it's just amazing. And Webb is doing everything that was designed to do. We said it will rewrite the textbooks, and it's doing so, right? It has found the furthest galaxy, the furthest star, and it keeps breaking that record, right? Getting closer and closer. It has looked at the life of stars, right? To see places where they are born. And of course, we know around those stars, planets will be born. Then the ending, those planetary nebula and the ending of those stars, multiple examples. It can also look at our solar system, and it has shown us, the rings for all our outer 4 planets, which we hadn't seen some of them for Uranus, for example, since Voyager went across, right? And to see those amazing images. And it's bringing new things. I think one of the ones that comes to mind for sure are those little red dots, right? These faraway objects that are really bright, are very red. We still don't know exactly what they are, if they're supermassive black holes, but we don't understand how they could be formed that early, and they don't show in other wavelengths like X-rays. So they seem to be different from other black holes, or if they are a very old star that's supermassive again. So it's telling us lots of things about that early universe and about different types of galaxies, right? We are finding many examples of unusual things, which is what was needed, right, to booster these models that we had of galaxy formation, star formation, and evolution, right? To learn, what is actually there. So it's very exciting. I think every day is something different.
N- Absolutely. And a question I got for you right now: what's kind of right now in this point in James Webb Telescope's mission? What's the main thing? Because obviously you're talking about the infrared, looking farther back in time. Is there anything, any particular project that James Webb is being utilized for right now in terms of utilizing that ability to look farther back with those infrared instruments here? What's kind of the big focus for the James Webb Telescope right now?
Yeah, I mean, it's observing all the time, right? Every year there is the call for proposals. The one for cycle 5, the 5th year, is just done, and they are scheduled, right? And the astronomers cover everything, cover this early universe. For example, one survey that was done that there is a focus now is to do these deep images, right? These deep, similar to the Hubble Deep Field, right? Which was a part of the sky where we thought there was nothing there, and Hubble looked at it for 12 or 13 days, and he found thousands of galaxies. So Webb has been able to do these fields just with much shorter integration times and looking much further back in time. But now there is a desire to start doing deeper observations with Webb, which show further and further objects. Webb also provided this data about what we call the Hubble tension, right? We know the universe is expanding, and in fact, it's expanding faster every time. We have early measurements that give a speed for that expansion that do not match the speed that we see near us. So that's something that Webb has been able to confirm data from Hubble with a lot more precision, saying there is something there that we don't know yet. And that's where this new, the Nancy Grace Roman, will be key to help us understand what the problem might be. And then, of course, it's looking for planets around other stars, but Webb is also able to see if those planets have an atmosphere. And of course, these are the little steps we are taking to eventually, hopefully, find a planet that looks like ours, right, in the sense that it has an atmosphere with components similar to what you will see on the Earth if you were up there, with liquid water and maybe a good temperature. And one of the ones that I have been watching is this system TRAPPIST-1, right? TRAPPIST-1, discovered with a ground telescope, is a redder star than our sun, but has 7 planets, and 3 or 4 of those planets are in what we call that habitable zone where maybe liquid water could be there. And Webb has been observing each of them. The data for the first three has been released, and they don't seem to have an atmosphere, and they're very hot. But the astronomers working on the others, they're still analyzing the data. So I think, that would be very cool when we hear what we find.
We have a new telescope here that's going to be launched relatively in the near future. That is, of course, the Nancy Grace Space Telescope. Dr. Vila, can you tell us more about this new telescope here, when it's going to be launched, and kind of what sort of different sort of operational roles are going to play compared to JWST?
Yes, so this is the Nancy Grace Roman Space Telescope. Is the first one named after a woman, which is pretty cool. She was the first chief astronomer at NASA in the time when Hubble was being built, and they call her sometimes the mother of Hubble, as she was key on that telescope and many other scientific things at NASA. And we are so excited to welcome the Roman telescope to work with Hubble and Webb. So Roman is going to go 1 million miles away, so it's going to go where Webb is. But what it's able to do is take a panoramic view of the universe. It can take an image that is about more than 100 times wider than the ones we can take with Hubble and Webb. And that's going to be key. So it's going to be a survey telescope that's going to map the universe in the infrared. It cannot see as far as Webb, but it can give us this wider view, right? We are seeing all these amazing things with Hubble and Webb, but they are like tiny pieces of the sky. It's like looking at the sky, we say, with a straw, and those amazing images is what we are getting. And now we'll be able to get this wider image and looking for information about what that dark energy that we mentioned before, what could it be, and also the dark matter, right? We are seeing the effect of both on the universe. We know dark matter and dark energy make 95% of what's out there that we don't know, and we are trying to learn what it is. It's also, with that wide view, going to expand the number of exoplanets, planets around other stars we are going to see. At the moment, we know about 6,000. We keep finding more. When Roman is on orbit, after a few years of operation, we'll have 100,000. And that's what we need to find something special, which, again, this search for something that could look like the Earth. So it goes with this instrument, the wide field instrument, which has 18 cameras that are the big ones that give us this wide image. And then it's carrying another instrument, which is a coronagraph. And a coronagraph is something, a fancy word, or you probably already know it, that covers the light of a star to be able to see if we see planets around it. And it's something very difficult to do because the stars are very bright, and the planets we are looking for, like the Earth, are smaller planets that are closer to the star. So this coronagraph has a new technology using deformable mirrors to remove the light of the star. So we are hoping to be able to find something like a Saturn and a Jupiter directly imaging. We are not quite there able to find an Earth-like this way, but it's definitely moving in that direction. So it will be pretty exciting once it's out there.
And what you were talking about before we started recording, you were talking about being in French Guiana for the launch of James Webb on a ESA rocket. And this time we're looking at a kind of a launch window that begins this fall, aren't we? For Roman.
Yes, indeed. And this time we are launching from Cape Canaveral. We are launching on a Falcon Heavy, and it's launching, we used to say early September. I mean, this mission is ahead of schedule and just a smidgen under budget, which is amazing. It's the first of these, what
It's
we
got to
call,
make people happy.
Yeah.
I know, these what we call flagship missions, right? These missions that are selected every 10 years that need to develop new technologies to achieve something that the astronomers want to have defined as the next thing they want to find out. So we are very excited, and I think we are almost ready to announce that we are working to a launch date of the 30th of August. So definitely early September from Cape Canaveral, and we should all be excited to see it at that time. And then looking for those first white images. We have about 3 months of commissioning to get everything ready after we launch. And after that, it will be amazing. And anything interesting we see, we can focus down in more detail with Webb and with Hubble. So we are very excited with this new telescope getting up there.
And I'm going to go back to James Webb for one thing. It launched on Christmas Day.
Yeah.
It launched on Christmas Day. So this is going to be our Labor Day telescope.
Labor Day, yes. I was so excited that I was lucky to be part of the support team for Webb, the French Guiana. And also I was lucky to do the broadcast for the launch in Spanish that NASA put out. So it was so special for me to be doing it. My mom does not speak English, so to be able to have been working on Webb for now 20 years. So it was super exciting, and I'll be there for the launch of Roman. So super excited as well to see this launch on close to Labor Day. Exactly.
Well, my mother-in-law's from Colombia, so I'll make sure
There you
she tunes in for your live broadcast. But that is all we have time for today. This has been an amazing conversation. Dr. Vila, one of the instrument systems engineers at NASA for James Webb Space Telescope, as well as the Nancy Grace Roman Space Telescope. That's going to do it all for our episode, but we got a little bonus here for you, Dr. Vila. We've got a special segment every week. My main man, my co-host, Matt Campbell, he always has a interesting little trivia thing. It's called Matt's Fact. Matt, what do you got for us today?
Well, the doctor already talked about Nancy Grace Roman, who was the mother of Hubble, as she was known. The other person we've been talking about, the James Webb Telescope, he was the second NASA administrator, and he was the one who was leading the space agency at the time when John F. Kennedy said, we're going to go to the moon by the end of this decade. And so he was the guy that put everything together for that program to go through and eventually get us to the moon on July 20th, 1969. So that's who James Webb is. And now you know who Nancy Grace Roman is for this other amazing telescope.
Love that edition of Matt's Fact this week. Again, that's going to do it all for us here for Ground Control on Queen C News Plus for Dr. Begonia Vila, and of course my co-host, executive producer Matt Campbell. I'm meteorologist Andrew Brightman. We'll see you right back here on Queen C News Plus for another episode of Ground Control. Take care.
Queen City News Plus. Just search Queen City News on your smart TV's app store.